did save the day. Here we go. We have sigma notation. We have our first example for the top of the sigma notation note page. What you're going to see in here next to the sigma is some kind of a formula. It might be 2n or 2n plus 1 or 2n squared plus 11. There can be any mathematical formula in there for you to find the sum of. We're going to start pretty basic and just look at 2n. All right? Under the sigma symbol, 90-some% of the time, they'll start you with n equals 1, meaning 1 is the first number that you're going to plug into the formula. At the top, they'll tell you when to stop. For example, we might stop when we get to 7. Why 7? I like 7. So there are a couple different angles you can take. Sometimes they'll give you this formula. You'll produce a series and add it up. Sometimes they'll give you the series and you'll have to rewrite it in this notation. I think that's more difficult. So let's see what we get. I'll show you how this produces a series. It basically says start here. Plug 1 in for n, and what do you get? What's 2 times 1? 2. Add to that, what number comes after 1? 2. Plug 2 in. What's 2 times 2? 4. Add to that, what number comes after 2? 3. We're going to keep plugging numbers in until we reach 7, and then we'll stop. That's how sigma notation works. It's almost like 1, 2, 3, 4, 5, 6. All these numbers are contained in this little letter, sigma, right? And they're just taking turns going in for n until you reach 7 and then stop. All right? So what comes next? Another thing this reminds me of is when we learned this, we had the houses on the street. How many? 7, right? What we're calculating here are their house numbers, their addresses, So what do you get when you put in 1? 2. Put in 2. 4. Put in 3. 6. Put in 4. 8. Put in 5. 10. Put in 6. 12. Put in 7 and stop at 14. That's how sigma notation works this way. It generates a list of numbers to add. Now, if you're sitting there thinking, wait a minute, did we have to write all those numbers out? Not really, if it's arithmetic. If it's arithmetic, what are the only two we actually need? The first one and the last one, and how many there are, right? All you really need to know, since it's arithmetic, is we could have done this. First plus last times how many over 2. So what's the sum? 16 times 3.5. 48 plus 8. 56. If you want to know why I did 48 plus 8, I did 3 times 16, which is 48, plus half of 16, which is 8. And 48 plus 8 is 56. So that's how sigma notation works in that direction. They give you the formula, you calculate it. Let's try it here. This is your first example that's printed on the paper. Let's go ahead and try to figure this out. And the first thing you should ask yourself anytime you're doing any of these problems is, question 1, is this arithmetic? Is this going to be an arithmetic sequence? I say yes, and I can tell because when I look at the formula, it's linear. It's a linear formula. It has a slope of what? 3, and a y-intercept of 2. If it's linear, it's arithmetic. You can use the formula. All right? So, listen, we could do it the long way. Plug in 1. Here's the long way. How many houses are on the street? How many houses are on the street? 8. Ranging from the first house on the street to the last house, which is number 8. How do we find their house numbers? Plug them all in the formulas, into the formula. Plug in 1. The first house number is 5. How do you find the last one on the street? Plug in 8. 26. Is that all I need to get the sum? This guy is arithmetic. So all you need is first plus last times how many? Over 2. We skipped all this because it's arithmetic. Save yourself some time. That's why we have formulas. All right? So it's 31 times what? 4, which is 124. Can you use the formula on B? No. This is of the form AB to the x power, so it's not linear, it's not arithmetic. For something like this, you would have to list out all the terms and add them up. Why did I make 5 spaces? There are 5 houses on the block. It goes from 1 to 5. How are you going to get the house numbers? How are you going to get them? Plug 1 in, get the answer, put it here. Plug 2 in, put it here. 3, 4, when to stop? 5, plug 5 in, okay? For now. Eventually, we're going to learn a formula to calculate that with a shortcut. So the homework again is the green worksheet for 9.1, 1 through 3.